Hey there, science enthusiasts! It's Bill Nye here, ready to take you on a wild ride into the heart of your computer. Ever wondered what's going on inside that humming box on your desk? Well, buckle up because we're about to find out. Think of your computer as a bustling city. Each component is like a different neighborhood working together to keep the city running smoothly. Just as a city needs power plants, transportation systems, and communication networks, your computer has similar systems that make it tick. Now you might be thinking, but Bill, computers are so complicated. And you're right, they are. But that's what makes them so fascinating. We'll use everyday analogies to help you relate to the technology. By the end of this journey, you'll be looking at your computer in a whole new light. So, are you ready to dive in? Great, let's start our exploration by looking at the brain of the computer, the CPU. Let's talk about the CPU, or Central Processing Unit. This little powerhouse is like the brain of your computer. Imagine if your brain could do billions of calculations per second. That's what a CPU does. It's constantly crunching numbers and making decisions to keep your computer running smoothly. On top, you'll find something called the integrated heat spreader. It's like a tiny metal hat that helps distribute heat. Under this hat is where the real magic happens. There's a small square of silicon called the die, packed with billions of tiny transistors. The CPU doesn't work alone, though. It has some helpers called cores. Think of cores as extra brains that can work on different tasks at the same time. The more cores a CPU has, the more tasks it can handle at once. That's why you'll often see CPUs advertised as dual-core or quad-core, but all this thinking generates a lot of heat. That's why CPUs need to stay cool, usually with a combination of metal heat sinks and fans. Now let's talk about the power supply. It's like the heart of your computer, pumping electricity instead of blood. The power supply takes the electricity from your wall outlet and converts it into a form that your computer can use. The power supply has to deliver the right amount of electricity to each component. Too much power could fry your components, while too little would leave them starving for energy. The power supply has different connectors for different parts of the computer, each delivering just the right amount of juice. You might have noticed that power supplies come in different wattages. The more powerful components you have in your computer, the higher wattage power supply you'll need. Safety is also a big concern with power supplies. They have built-in protections against power surges and short circuits. A good power supply will shut itself down if it detects any dangerous electrical situations, protecting your precious computer components from harm. Now, let's zoom in and look at the real workhorses of your computer integrated circuits and transistors. An integrated circuit is like a miniature city with streets made of metal wires and buildings made of transistors. Transistors are like tiny switches that can be turned on or off incredibly fast. Each transistor represents a bit of information, either a 0 or a 1. By combining millions or even billions of these transistors, we can create complex circuits that can perform amazing feats of computation. The story of transistors is one of constant miniaturization. When they were first invented, transistors were about the size of a fingernail. Now we can fit billions of them onto a chip smaller than a postage stamp. But we're starting to reach the limits of how small we can make transistors. At extremely tiny sizes, the weird world of quantum mechanics starts to interfere with how transistors work. Scientists and engineers are working hard to find new ways to keep making computers faster and more powerful. Who knows what amazing innovations the future will bring? Let's talk about something hot. Or rather, how we keep things from getting too hot. Computer cooling systems are crucial for keeping your machine running smoothly. The simplest cooling system is the Humble fan. These work just like the fans in your home, but computers often need more than just air cooling. That's where liquid cooling comes in. It's like giving your computer a refreshing drink. Liquid coolant circulates through pipes, picking up heat from components. Heat sinks are another important part of cooling systems. The fins increase the surface area, allowing more heat to dissipate. Some high-performance computers use exotic cooling methods. There's phase change cooling, like your refrigerator, or immersion cooling, where the computer is dunked in a special liquid. These methods are for the most powerful machines, showing how important cooling is. Now, let's turn our attention to the GPU, or Graphics Processing Unit. If the CPU is the brain of your computer, the GPU is like its artistic side. It's specialized for creating the images you see on your screen. From the simplest desktop icons to the most complex 3D game environments, The GPU is hard at work, making it all look good. But don't be fooled. GPUs aren't just for making pretty pictures, they're incredibly powerful processors in their own right. While a CPU is designed to handle a wide variety of tasks, a GPU is optimized for doing many similar calculations at once. This parallel processing power makes GPUs great for more than just graphics. They're also used for scientific simulations, cryptocurrency mining, and even artificial intelligence research. GPUs generate a lot of heat, sometimes even more than CPUs. That's why high-end graphics cards often have their own elaborate cooling systems. You might see multiple fans, large heat sinks, and even built-in liquid cooling. All this cooling helps the GPU work harder and faster without overheating. Let's talk about the unsung hero of your computer, the chipset. If your computer were a city, the chipset would be its traffic control system. It manages the flow of data between different components, making sure everything gets where it needs to go. The chipset is usually split into two main parts, the North Bridge and the South Bridge. The North Bridge handles high-speed connections, like between the CPU and RAM. The South Bridge, on the other hand, manages slower connections, like USB ports and hard drives. Modern chipsets are getting smarter and more integrated. Many functions that used to require separate chips are now built right into the CPU. This integration helps make computers faster and more energy efficient. It's a great example of how computer design is always evolving. When you're upgrading your computer, it's important to make sure new components are compatible with your chipset. Otherwise, it's like trying to park a jumbo jet in your driveway. Let's take a quick tour of other important computer parts. First, the motherboard, the foundation of your computer. Next, RAM, or random access memory. It's your computer's short-term memory. Storage devices are your computer's long-term memory. SSDs have no moving parts, unlike hard drives. Finally, input and output devices, keyboards, mice, monitors, essential for interaction. Let's take a quick trip down memory lane and look at how computer hardware has evolved. It's a story of constant innovation and miniaturization. The first computers filled entire rooms and had less processing power than a modern calculator. They used vacuum tubes instead of transistors and had to be programmed using punch cards. The invention of the transistor in 1947 was a huge leap forward. Transistors were smaller, faster, and more reliable than vacuum tubes. This led to the development of integrated circuits in the 1950s. Suddenly, we could pack more and more computing power into smaller spaces. The personal computer revolution of the 1970s and 80s brought computers into homes and offices. Companies like Apple, IBM, and Microsoft became household names. Today, we carry more computing power in our pockets than was used to send astronauts to the moon. Smartphones, tablets, and laptops are everywhere. And the evolution continues with things like quantum computing and neuromorphic chips that mimic the human brain. Who knows what amazing computer hardware we'll be using in another 50 years. Now, let's talk about something really important. Engineering education. All these amazing computer technologies we've been discussing, they were created by engineers and scientists who spent years learning and experimenting. Engineering education isn't just about memorizing formulas or learning to code. It's about developing problem-solving skills and creative thinking. It's about looking at the world and asking, how can we make this better? Engineers are the ones who turn science fiction into science fact. But here's the thing, we need more diversity in engineering. We need people from all backgrounds, all genders, all ethnicities, bringing their unique perspectives to the table. Different viewpoints lead to better solutions and more innovative ideas. It's like having a toolbox with only one type of tool. You're limiting what you can build. That's why it's so important to support STEM education programs, especially those that reach out to underrepresented groups. We need to show kids that engineering isn't just for math geniuses or computer nerds. It's for anyone who wants to make a difference in the world. We've taken quite a journey through the inner workings of your computer, haven't we? From the brain-like CPU to the artistic GPU, from the power-pumping PSU to the data-directing chipset. The real magic happens when all these parts work together in harmony. It's like a symphony orchestra. Each instrument is impressive on its own, but together they create something truly spectacular. Think about what happens when you turn on your computer. The power supply springs to life, sending electricity coursing through the system. The CPU wakes up and starts reading instructions from memory. The GPU prepares to paint pictures on your screen. The cooling system stands ready to whisk away excess heat. All of this happens in the blink of an eye, coordinated by the chipset and the operating system. It's this incredible coordination that allows you to do amazing things with your computer.
Thanks for tuning in. Remember to hit the subscribe button, give us a thumbs up, and drop a comment below.